Hi, my name is Sean Doyle, and this is the third video in my multi-part video series entitled Introduction to Programming for FRC Robots. And in this video, I'm going to be talking about sensors and actuators. Now, at first glance, these seem like pretty big topics that might require videos on their own, but in reality, the amount of programming that goes into sensors and actuators is actually not as much as you might think. And this programming is oftentimes so general that I think I can cover both of these topics in one video. So the first thing I want to talk about is what is a sensor, just so that everyone's on the same page. And I would define a sensor to be anything that can observe the world around it. So for example, on a human, we have these 5 senses, and we have certain things like eyes and ears and a nose in order to observe the world through sight, hearing, and smell. A robot has sensors in order to observe the outside world. So for example, here I have a limit switch, which observes the world through touch. When this bit is touched right here, the robot can sense that. And over here I have a NavX gyroscope, which is used to observe the angle of a robot through accelerometers and acceleration. So now that we've quickly defined what a sensor is, it makes sense to quickly define what an actuator is. And now an actuator is just anything that causes motion. So once again, following with the human example, I have the muscular system here because your muscles are what causes motion within your body. But on robots, we have things like motors and pneumatics in order to cause motion. To be honest, programmers and code don't really care about actuators in particular. Like, we don't care what kind of motor is being used or what kind of cylinder for pneumatics are being used, or even if you think of it in a human example, what kind of muscles are being used. What we care about are the controllers that are controlling those actuators, because it's the controllers that are what programmers talk to and what we program. So instead of what an actuator is, why don't we talk about what an actuator's controller is, which in this case for a human, it's like the nervous system. The nervous system is what controls those muscles. For a motor, it could be a SparkMax motor controller or any type of motor controller. And for a cylinder, it would be a solenoid like this. So it's these parts that a programmer would care about, because these are the types of things that programmers actually interact with and program in order to get actuators to do things. Let me just note that on our team and in our code base, we talk about actuators as if they're the actuators controllers. So for example, we have a folder in our code base entitled Actuators, which I'll get to in a bit. But in this actuators folder, we have classes that are used to interact with things like motor controllers and solenoids. So even though I might say actuators later on, you can just equate that to the controllers of actuators, because that's really what I'm talking about when I talk about an actuator. It's a very subtle difference, but should be noted. So in our code base, our actuator and sensor classes are what are called wrappers. So in programming, a wrapper class is a class that takes complicated internals and hides them away or simplifies them for the user so that they make more sense within that particular code base. In much the same way as a wrapper protects and provides an appealing appearance to a piece of candy, like I have down here, that's the same idea within programming, that a wrapper class provides an appealing or useful outside appearance to a set of internals that may be very complicated or hard to understand. So that's the meaning of these images down here. Up here, I have a quick example, like an infrared distance sensor, which is just a sensor that detects how far away something is using infrared light. So in this case, an infrared distance sensor is an analog input, which is very not specialized in general. And so an analog input can do this thing called get voltage. But in this context, get voltage is going to return the infrared distance. So there's a method here that's called get infrared distance, which is in the wrapper class, which all it does is returns the voltage of this analog input. But what's significant here is that get infrared distance is a descriptive name that makes sense within the context of the code base, because it describes what's happening, whereas get voltage is not very descriptive. So this wrapper class allows for the code base to make a little bit more sense because it has a descriptive method name as opposed to just this general get voltage, which is a property of an analog input. So this is perhaps the most important slide for defining what qualifies as an actuator or what qualifies as a sensor within our code, because if a certain input, like an analog input or a certain speed controller, requires some sort of wrapper, some sort of extra explanation as this infrared distance sensor did, then it requires a class within the actuator or sensors package. So something special that our team, Team 4905, has done this past year and the past couple of years is that we have real and fake sensors. So within our code base, for each of our sensors, we have a base class that provides an interface for that sensor. And then we have two different classes derived from that base class. So just like I talked about in the previous video about superclasses and subclasses, the base class would be a superclass in this case, which provides a common interface for interacting with a particular sensor. And then two base classes would be a real sensor, which has certain properties such as a port number, for example, and certain specializations of the base class's methods. And then there's also a fake class, which also derives from the base sensor class and is another subclass of that base sensor class, which is just used to stand in for that sensor when it is not on the robot. So what this basically allows for us to do is it allows for us to take off a sensor from the robot and then specify in a config file, which I'll talk about more in a later video, that we no longer have that sensor, and in that case, a fake sensor will be created. Now, this is something very specific to our team, like I mentioned, and it's also something that we do with what are called subsystems, which I'll talk about later, but we don't do this trick with actuators because of our ability to make real and fake subsystems. So actuators just don't need this capability, but it is very useful for when we're interchanging sensors or switching between robots to be able to specify, oh, this robot has a real camera versus, oh, this robot doesn't have a camera on it, so we'll just create a fake camera. Why don't we jump into some examples? Okay, so now that we're in Visual Studio Code, the first thing I want to draw your attention to is the folder system over here. So as you can see, under Java FRC Robot, there's this folder called Actuators, which is where we store all of our actuator classes. And then there's another folder called Sensors, which is where we store all of the sensors classes. So in this sensors folder, there are also subfolders for different sensors, like the camera, like the gyro, infrared distance sensor, all these types of sensors. And if we look at one of these, why don't we look at the limit switch sensor? You'll see limit switch sensor, mock limit switch sensor, and real limit switch sensor, just like I talked about on that last slide, where we have this base class and then two classes that derive from it. So why don't we take a quick look at the base class? So here is the base class. I didn't talk about this in the previous video, but this is what's called an abstract class, which all that means is that any class that derives from this class, any class that's a subclass of this class, has to override and change any methods that are also abstract in this class. So just like how I talked about in the previous video about overriding methods and how useful that is, what an abstract class does is it forces subclasses to override that method. Hopefully that made some sense for you. Anyways, we have one method here called isAtLimit. So it seems like this sensor is very simple, which makes sense for a limit switch, where all it says is it tells you whether or not the sensor is at the limit. So that's all that this base class does. And then if we go into the real limit switch sensor, we can see that it extends that base class limit switch sensor. And then it also overrides that isAtLimit method. So it's going to return limit switch.get, and limit switch is just a digital input. So once again, this is an example of a wrapper class at work. This real limit switch sensor is a wrapper class, which is just kind of wrapping up this digital input object called limit switch, because digital input has this nice method called .get, but that's not very descriptive for a limit switch sensor. So instead, limit switch sensor provides this method isAtLimit, which is more descriptive for what a limit switch is going to do. And then this has the nice useful thing, reverse polarity, which allows the limit switch to return the opposite of .get if the polarity is reversed. That's pretty much all we need to know for this isAtLimit method. We can go up and look at the constructor for real limit switch sensor. All that's happening in here is some configuration file stuff. Like I talked about earlier, we have this special config file, which specifies what kind of sensors and actuators are on the robot, but I'm going to be talking about this more in depth in a later video, so don't worry too much about everything that's happening in here. Okay, why don't we take a quick look at a mock limit switch sensor? So here is mock limit switch sensor. This sensor also derives from limit switch sensor in the same way that real limit switch does. Extends limit switch sensor and extends limit switch sensor. But as we can see, it's much simpler. It also overrides is at limit because it has to, because limit switch sensor is an abstract class. But as you can see, all it does is return false. So there's nothing special in here. A mock limit switch sensor is only created when the limit switch is not actually on the robot. So it kind of makes sense that is at limit would be very simple. It would just return false, not do anything. Okay, why don't we take a look at a actuator? So here I have a double solenoid actuator. So like I said earlier, technically a solenoid is not an actuator. The actuator would be a pneumatic piston, but we just refer to them as actuators here, even though they're really actuator controllers. So in this case, there is a class provided for us called double solenoid by WPI, but we have our own wrapper class, double solenoid 4905, which just makes a little bit more sense for us to use. So for example, our double solenoid 4905 class has this method extend piston, which calls the double solenoid, which is just uptype double solenoid, dot set forward. And what this allows for is a little bit more description within what m under double solenoid dot set k forward does. So oftentimes we'd run into the problem where the programmers would say, oh, we're setting the solenoid to go in k forward, and everyone else will say, well, what the heck does that mean? This wrapper class avoids that problem because now anyone who uses double solenoid 4905 must call extend piston. They can't call this dot set k forward randomness. They have to call extend piston. So it's very clear what double solenoid 4905 is trying to do. Then we have just some other methods down here. Retract piston does very similar stuff, and stop piston sets the piston to an off state. Once again, the constructor is just looking at some configuration stuff, which we don't have to worry about. And is solenoid open is just a nice getter method, which is returning the state of the solenoid. Okay, so I think that concludes this video. Actuators and solenoids are going to be building blocks for the rest of our code base. These are going to be very useful when talking about other things like commands, group commands, PID controllers, and lots of other folders and classes that we have within our code base. Hopefully these didn't come across as too complicated or too advanced. Just the big takeaway is that sensors and actuators are meant to be wrappers. They're meant to hide away complicated internals in such a way that it makes more sense within the code base. So I've shown you some very simple actuators and sensors, but if we were to, for example, look at the Navex gyro sensor, this is a much more complicated sensor that requires a lot of setup and a lot of different calibrations in order to just get an angle out of it. So that's the whole idea here, that sensors and actuators are hiding away these complicated internals in such a way that it makes sense for users to use these sensors. Thanks for watching.